Hey there, and welcome to BridgeText.com's tutorial on multicollinearity testing in Stata. Now, multicollinearity is one of those words that's very annoying. It shows up in statistics. Here's what you need to do, unless you're obsessed with it, then you can go out and research it. You just need to know how to run the test and what to change so that you do not have a multicollinearity problem. So that's how we will proceed without a lot of theories, without a lot of definitions. Let's first pull up a data set so we can create a problem, a multicollinearity problem, and then go ahead and solve it. So I typed in sysuse auto here to pull up Stata's built-in 1978 automobile data in which nobody on earth is interested. And then I went ahead and described it so you can see what we have. Right, so it's a lot of variables pertaining to cars from 1978. Now, multicollinearity is something that's going to happen after a regression. So we're going to have to go ahead and create a regression model, and here's what I've done. Regress is the command. The first variable here is your dependent variable. So I've put in miles per gallon, I've put weight, I've put length, and notice there's nothing in here called I foreign. The I and the dot here are just to sort of tell Stata that foreign is a categorical variable. So it's a little shortcut. So, you know, we're dealing with something that is like foreign and domestic, and you're going to see how that works out actually when we run the model. So notice that kind of created a dummy variable for us automatically, that I dot, telling us that if a car is foreign, it's going to have, let's see, no statistically significant effect on miles per gallon. We have weight and length here. Weight is significant, length is not. However, our interest is in doing the multicollinearity test. So we're going to go ahead and type in VIF, stands for variance inflation factor. And we get one for each of the variables in our regression. Now, typically, we see some different stuff. Some people say a VIF over 5. Some people say a VIF over 10. I'm going to go with 5 as a cutoff. It's a problem. So if you start saying VIFs here that are over 5 and here, they're quite close to 10. We have multicollinearity. Now, what does that mean? It means that the variables that have high VIFs over here are also correlated with each other. And how can we check that? Well, we know that weight and length are the variables with high VIFs here. So we're going to type in pwcore. That's our Pearson correlation command in Stata, comma, space sig, to see how significant that is. And wow, not surprisingly, I guess, weight and length are significantly correlated with a Pearson R of 0.946 and very statistically significant. Now, because they're correlated with each other, we can just go ahead and actually kind of remove one and then do our test again, our VIF test of multicollinearity, and see what happens. So let's go ahead and rerun that, and I've just taken out height. It doesn't matter which one you take out. They're correlated with each other. So I've taken out, yes, height. And so now we get weight as being significant. And let's go ahead and compare our model diagnostics to a little bit. One thing that's important is let's look at the adjusted R squared, right? So with our two variables now, we can still explain about 65.32% of the variation in miles per gallon. And if we go over here to what we had earlier, notice that the adjusted R squared wasn't that much better when we had both weight and height. So this is a bit more parsimonious. It's a more efficient model. We didn't lose much explanatory power at all. And most importantly, VIF is no longer a problem. So that is how you detect and correct for multicollinearity in Stata.